And hello, we're going to go ahead and continue talking about motion, and in this lesson we're going to talk about velocity. Okay, velocity. Now in everyday science and even everyday life, primarily the terms velocity, and I'm going to put in quotes here, speed, are often interchangeable. Velocity means speed, speed means velocity. But in physics, we're actually going to distinguish between the two. Velocity is, I'm going to draw this nice little arrow here, it is speed in a particular direction. Oops. Okay. For example, here is a measure of speed. For example, 60 miles per hour. Okay, 60 miles per hour. That is speed. Okay. Now, 60 miles per hour north. Okay, that right here, 60 miles per hour north, this is a velocity because it has speed, which is 60 miles per hour, but then it also has direction, which is north. So here's speed, okay, and here is direction now. Okay, speed and direction. So velocity is a measure of speed in a particular direction. Speed in a particular direction is velocity. All right, so now we're going to talk about two things here. We're going to talk about constant speed and versus changing, excuse me, not constant speed, constant velocity versus changing velocity. Now for the typically when you're driving down the road and you have your car, okay, here's a nice car. Forgive the wonderful graphics because I am not a artist by any means. So here's a car driving down the road, okay, driving down the road right there, okay, in that direction, okay. And when you have the cruise control set, okay, cruise control, you're driving, let's say you have your cruise control set at 60 miles an hour, okay. The entire time that it's set at 60 miles an hour, you are driving at a constant velocity. Okay? You're driving at a constant velocity. Okay? Now we know in everyday life you're not always at a constant velocity. Some people will start off walking slow and speed up. Some will start fast and slow down. You know, taking off from a stop sign. Okay, you got a stop sign. Okay, taking off from a stop sign, you know already that you do not start driving at 60 miles an hour. Okay, so you are speeding up and you're slowing down, and this different kind of motion all the time, speeding up and slowing down. So we're not always at a constant velocity. A majority of our daily life is at a changing, okay, changing velocity. Okay. Okay, we're at a changing velocity. We're either speeding up or slowing down. Okay, so we have this changing velocity. Okay, velocity is for the most part always changing, and here's why. Okay, let me clear the screen here. Velocity, if speed or direction, okay, changes, then velocity changes. Okay? So for example, we take our car. I'm not going to drive another car again. I'm just going to, here's this object, okay? We're going to call it a car. I know I can't draw, so I'm not going to pretend I can. So car, we got a car, and it's driving down the road at 60 miles an hour. 60 miles an hour north. Okay, we're going north. Let's say as you get the car gets halfway down the road, down to here, okay, right here at this green star, okay, it speeds up, okay, and goes, at this point in time, 65 miles per hour. But it still goes north. Same direction. The only difference between here, A, and B, is that the speed changed. The direction stayed the same, but the speed changed. Because the speed changed, velocity changed. Okay? Now, here's another example. Okay? Let's say you got the same car. Okay? Again, not going to draw it. Okay? You got the same car driving down the road. Okay? And this time, it's driving 60 miles an hour. And right here at this this little star, it has to slow down to 40 miles an hour. Okay? Oh, by the way, 60 miles an hour and we're still going north. 40 miles an hour and we're still going north. Again, speed changed, therefore velocity changed. Okay? Now let's say we have the same car. Here's another example. Same car driving down the road. Okay? This time they're driving, oh, I don't know, let's say 25 miles an hour, okay? 25 miles an hour. And when they get down to the end of the road, down here at the very end, okay, they change directions. 25 miles an hour and they're going north, okay? And they change directions and they take a right, okay? At this point in time right here, okay? And they're still, at this point, still driving 25 miles an hour, okay? But now they're going east, okay? Their speed didn't change, but their direction, because they went from north, right here, to east, their direction did change. Because their direction changed, velocity also changed. So, to recap, if velocity changes, it changes because speed changed, or direction changed, or both. If either or, if speed changes, or direction, or, and I'm going to put and or direction changes, velocity changes. Okay? Alright, let's go ahead and let's do some practice with velocity and calculating velocity with just some basic mathematics. Okay, so remember, velocity and speed kind of go hand in hand. Okay, so number one, let's try this. What is the speed of a rocket that travels 9,000 meters in 12 seconds. Okay? Remember, velocity is a measure of distance over time, a rate, okay, time. And we talked about that, the distance over time, it's a rate, okay? And that's exactly what velocity is. It's going to be a distance divided by a time. So in a problem like this, we're given, here's our distance. Our distance is in meters right here, okay? And our time is in seconds. And we're given two numbers for that. Okay, we're given 9,000 as our distance, 9,000 meters, abbreviated M, over our time is 12 seconds. Okay? And we can pump this into a calculator. And pumping this into a calculator, 9,000 divided by 12, okay, gives me 750. 750 what? Well, meters doesn't cancel seconds because they're different units. They're not the same. It's apples and oranges. So I'm still left with meters per second. So it's 750 meters per second. Okay, that is how fast the rocket is traveling. That's its velocity. Okay, its distance over time. Oh wait, now let me back up there. It's not actually its velocity. It's its speed. What is the speed of a rocket? And the reason this is speed and not velocity is that it is a distance over time, which is speed and velocity. Like I said, that they're related. It's a speed, but it doesn't have a direction. Okay, there's no direction listed here. All it's listed is the speed portion. Okay, there's no direction. Now, if we had said that what is the velocity of a rocket that is traveling 9,000 meters in 12 seconds towards the moon, okay, and you did the math and calculated it all out and said, oh, the rocket is traveling at 750 meters per second, okay, towards the moon, okay, towards the moon. That towards the moon right here that I'm putting in quotations, that is actually a direction. Okay, so in this case, this is a velocity. Okay, this is a velocity right here, 750 meters per second towards the moon. Now, if you just say 750 meters per second, that is speed, not velocity. Now, to wrap up this discussion on velocity, I'm going to give you a little bit of a formula, okay? So whenever we are talking about velocity, okay, we are always referring to velocity in mathematical formulas as a lowercase v, okay? It's always referred to as a lowercase v. And velocity, v, equals, okay, distance over time, okay, plus it also has a direction attached to it, okay. Distance or velocity equals distance over time, okay. Now, sometimes you'll be given in various problems, you'll be given velocity and time and asked to solve for distance. And so using some basic algebra, you should be able to rearrange the formula. So distance in this case equals velocity times time, okay? To finish it out, to calculate time, time equals distance divided by velocity. Okay, so we have our three formulas there, and remember that velocity is always a distance over time plus in a direction. Distance is typically velocity times time, which actually just gives you a distance, like in miles, meters, okay. Oh gosh, centimeters, lots of different distances, okay? And time is a measure of time. You can have hours, you can have seconds, you can have years, okay? Lots of different ways to measure time.